Hello students, we have learned in a previous clip that our equation of a force equals to BQV sine theta. We have presumed that k equals to 1, it's a value of a constant, and in all those theorems we have proved that the unit of a magnetic field, it is 1 Tesla, that theta was ideal value, that is called as a 90 degrees. But right now we want to move and show something that our q is called as our scalar quantity, while your magnetic field and your velocity both are called as vectors. Now I want to correlate this thing and show that whether it is following that cross product or it is called as a vector multiplication. In 11th science you are aware about A cross B is equals to modulus or magnitude of vector A and vector B, and that is called as its angle between them, or generally you are habitual to place that AB sin theta. So right now we have a q which is called as a scalar quantity and these two are called as a vector. So I am first of all placing that vector f equals to q and it is called as a v cross b. Here instead of v we can just say that v is called as a velocity. Another thing, it is called as a vd. Yes, after end of this chapter gradually you will learn that it is also called as a drift velocity. So both are part of a scalar part, vector part. So v equals to vector vd, it is drift velocity. So you can also place this thing over here, f equals to vector vd cross b. So this equation is called as a Lorentz forces equation or Lorentz equation. With the help of Lorentz equation you can learn that what amount or force or in which direction our force has been applied. You can just with the help of this notation you can apply one rule that is called as a Fleming's left hand rule. Fleming's left hand rule is suggesting us something that is called as a force, field and current notation. Let's say I have three axes x, y and z. In the x axis I am putting that magnetic field B. On the y axis my force is F. So this is the z axis on which I can either find it out my charge or maybe the flow of the charge, which is called as our current. General term is called as a q by t. So in a Lorentz force we have placed that values of a theta. Same is the course. First of all we are just finding it out these values. I can see that it is called as our thumb rule. Our first finger, it is called as index finger, is indicating our force. Then our second finger, it is called as our middle finger, is indicating our magnetic field B, while our thumb, the direction of the thumb, it is called as generally. We are aware that whenever we have such type of our finger arrangement, our force, it is called as a electric force, or you can say magnetic force or given force. B is called as a field, magnetic field, and this direction of a thumb is giving us the direction of the charge, or it is called as a giving us the flow of the current. So generally Fleming's left hand rule is called as FFC. It's denoted as a force on the y-axis, field, it is magnetic field on the x-axis, and C is called as a current on the z-axis. So generally it is called as FFC. Yes, by changing their directions, if instead of F I am putting F on the x-axis and I am putting B on the y-axis and changing the directions, automatically angle will be changed. So my equation will also be modified. Instead of first of all I am putting that theta equals to 0, so there will be no force. If my theta equals to 270, so that would be QVB, and the sine 270 degree, it is giving me minus QVB. So as per your directions you are changing on FFC or Fleming's left hand rule is suggesting us that your direction of force will be also been changing or affected, because Q is called as a scalar quantity, but while B and B are called as a vector quantities, so values are keep on changing. We can also denote or remember this equation with a general uh, nomenclature figure. It is suggesting us that direction of f with the help of this general figure. Let's say I am putting that over here, it is positive only because this is the direction of your theta velocity. If your magnetic field will be over here, your force will be over here, it means it is called as a sine 90. So this is the value you can receive. Your force equals to qvb sine theta, which will be called as f and b, both are positive. Or I am, instead of f on the positive y-axis, if I am changing and placing it in this direction, so it would be giving me negative value. So this is called as f. My theta will be as it is, but my equation will be look like minus qvb sine theta, or you can say that vector f equals to minus q. It is called as a v cross b. So you can just directly see that whether I have just taken f positive, instead of after changing its value I got a negative answer. You can also place it like that. You are aware about the cross product properties. I cross j cap is called as a k cap, but instead of I am putting that j cross I cap is called as a minus k cap. Same term you can observe over here. This one is a positive sequence part, so I got positive. After changing their values and direction, I got the negative answer. So with such type of general theory, you can learn how it has been changing. There is another short form abbreviated part in the our Biot-Savart's theorem. We will learn that it is called as a snow theory. It is termed as south to north. Our direction of a magnetic field lines are passing, and so our result we will observe over the westward side. So in the next clip we will move towards the very important theory of this chapter. From that we will derive different type of formulas, equations. It is called as a Biot-Savart's theory. So next theory we will learn, it is called as a Biot-Savart's law.